Hello everyone. Today we are going to begin our lecture on the sixth section of chapter 3 on logic, and this section is about the Euler diagrams and syllogistic arguments. Now, Leonhard Euler, he was a famous Swiss mathematician, physicist, and a lot of other things together. He was a polymath, and among his many contributions in the field of mathematics and science, he came up with a way of evaluating syllogistic arguments using diagrams. And those diagrams are today known as Euler diagrams. So in this section, we are going to talk about what those diagrams are and how to use them to evaluate arguments in logic. All right? So here's what we are going to learn in this section. We are going to first understand what Euler diagrams are, how to come up with Euler diagrams from the different arguments, the premises, the conclusion, and so on. And then we are going to learn how to use them to test the validity of the different syllogistic arguments. Now, in chapter 3, we spend quite a bit of time talking about symbolic arguments, how to come up with truth tables, how to test their validity, and so on. We will now talk about another kind of argument, which is called a syllogistic argument. It's also known as syllogism, and to validate and test such arguments, we will be using what's called the Euler diagrams, which we will learn about. All right, so the only way we can test syllogistic arguments is by using Euler's diagrams. Now, in a symbolic arguments, the words and phrases that we have used were the and, the or, the not, the if then, the if and only if. Those were the different words and phrases in symbolic arguments. In syllogistic arguments, we will look at statements that begin with all are, some are, not all are. This is something that we had briefly touched upon in the very first section of this chapter, but we are going to revisit such statements and then look at arguments using those statements. All right? So what are Euler diagrams? Euler diagrams are similar to Venn diagrams, and they serve to determine whether an argument is valid or not, whether it's a valid argument or if it's a fallacy. So we use circles as in Venn diagrams to represent sets in syllogistic arguments. All right, so you will be able to relate a lot of these Euler diagrams with Venn diagrams and also with the knowledge, with some of the information we had learned in chapter 2 when we were studying sets. Now let's do a quick comparison of symbolic arguments and syllogistic arguments. Now, in symbolic arguments, we saw the statements contained words and phrases like and, which was the conjunction, then or, it was disjunction, not, negation, if then was the conditional statements, and if and only if were the biconditional statements, and then many of the statements, compound statements, were a combination of these words and phrases. And to test the validity, to determine the validity of symbolic arguments, we use truth tables, or we just compared the statements with standard forms of arguments and came to a conclusion whether the argument was valid or not. In syllogistic arguments, the statements will have phrases like all are, some are, none are, some are not, and so on. And the way we go about determining the validity of syllogistic arguments is by using Euler diagrams. Let's look at an example of syllogistic argument, all right? And then we will also learn how to determine the validity of it using an Euler diagram or Euler diagrams. So the arguments, the first two statements are premises, right? These two statements represent the premises, and then the last one here with the therefore would be the argument, the argument. Correct. Now, the first premise says all harmonicas are musical instruments. The second premise says a trumpet is a musical instrument. And then the final argument or conclusion says, therefore, a trumpet is a harmonica. So how do we go about testing its validity using Euler diagram? Again, you will see it's very similar to sets, the idea of sets and Venn diagrams. So we will first draw the diagram related to the first two premises. All right, so the first premise can be drawn like this. So let me pull up the pen here. Recall that when we were talking about Venn diagrams, we had a rectangular or a square box, and that represent the universe. And inside the universe, we have a set of musical instruments. All right, so we are going to draw a circle that will represent all musical instruments. So, and then it says here, the first premise says, all harmonicas are musical instruments. That means harmonicas are musical instruments. They should fall within the circle of musical instruments. So it should be a subset. We should show it as a subset of all musical instruments, correct? So H. So harmonicas are subsets of musical instruments. So that's why it's contained entirely within the circle of musical instruments. And then the second statement, the second premise or the second statement says a trumpet is a musical instrument. So since trumpet is a musical instrument, and they have mentioned just one trumpet, not all trumpets. So a trumpet is a musical instrument. So we're going to denote that using a small dot perhaps and represent that with the letter T. All right. So the trumpet should be within the circle of musical instruments, but not inside the circle of harmonicas, because trumpets are musical instruments, all right, but they are not harmonicas, so they should be outside the circle of harmonicas, correct? So now if we go ahead and draw the diagram, the Euler diagram, which will also include the argument, right? This final conclusion or the argument. This is how it's going to look like, and then we'll come back and see if it will match with what we got here initially to start with. So again, I'm going to draw my square or a rectangle to represent the universe, and then I'm going to draw a circle which will be the set of musical instruments, and then I'm going to draw my harmonicas, which would be a subset of musical instruments, harmonicas. But the argument says a trumpet is a harmonica, correct? So that would mean that the trumpet should be within the circle of harmonicas, which is not correct. It doesn't match. This diagram doesn't match with the diagram we came up from just the premises, correct? So there's a mismatch here, and that will tell us that this is an invalid argument. All right, this will make it invalid. This is an invalid argument because it does not match the diagram we got from the two premises. All right. So next we are going to look into the solution and see if they have come up with the same conclusion. All right. And if they have worked it the same way as we have using the Euler diagram. Now let's study the solution that they have provided for the argument that we worked previously. I have the argument written out here. It says premise 1 is all harmonicas are musical instruments, and premise 2 says a trumpet is a musical instrument is what it should be, not an. So a trumpet is a musical instrument, and the conclusion said, therefore, trumpets are harmonicas. So we have to validate this argument with Euler diagrams. Now, the first picture here, the first diagram is just for premise 1, which says all harmonicas are musical instruments. So the bigger circle is for musical instruments represented by M. And because all harmonicas fall within the set of musical instruments, they are all musical instruments, we have the circle or the set of harmonicas contained entirely within the circle of musical instruments. All right, so that is for premise 1. For premise 2, we have this diagram here. The diagram B includes premise 2 into premise 1. All right, it incorporates premise 2 in premise 1. So we have again the set of all musical instruments, and within it we have the set of harmonicas, which was the same as what we had in A. And then we have to incorporate a trumpet is a musical instrument. All right, now, because they are referring to a single trumpet, a trumpet, we do not use a circle. We just use a dot represented by the letter T for the trumpet. And it says here in the premise that it's a musical instrument. It doesn't say that it is whether it is also a harmonica or not, correct? Therefore, we have to place this dot T, the trumpets, outside the set of harmonicas. It is within the set of musical instrument, but nowhere in the premises it states that trumpets are also harmonicas. Therefore, it has to be placed outside the circle of harmonicas. All right, so this is picture B. Picture C shows how the diagram would be if we included the argument. All right, if we included the argument. So based on the conclusion, it says trumpets are harmonicas. So if we include the argument and draw a picture, we see that trumpets would be contained within the circle of harmonicas, which is not what the two premises say. Correct? Therefore, this is an invalid argument. If picture C matched with picture B, then we would have concluded that they are it's a valid argument. But because the picture C is very different from picture B, the conclusion is that it's not a valid argument. So I'm going to pull up the explanation here. It says all harmonicas are musical instruments is illustrated in picture A, and then a trumpet is a musical instrument is shown in B. However, picture C is not the same as picture B. All right, we see that a trumpet is not a harmonica, therefore the argument is invalid, or it is also called a fallacy. An invalid argument is also known as a fallacy. Let's look at a second example now. It says here, no birds are mammals. That's the first premise, right? Premise 1. And then we have the premise 2 saying PT is not a mammal. So that's premise 2. And then the argument says, therefore, PT is a bird. Again, we are going to use Euler diagrams to come up with a decision. So when they say no birds are mammals, how would the picture of that look like? So here we have our square of the universe, and then within it we will have two sets. One is for the mammals and the other one for the birds, correct? So let's draw the circle for mammals, and then another circle will be for birds, but it says no birds are mammals, so birds will not be contained within the circle of mammals. And let me mark this as M for mammals. So we have to draw another circle, another set of birds, but there's no commonality between the two. They are disjoint sets because in premise 1 it says no birds are mammals. And then the second premise says PT is not a mammal. So it's not a part of mammal. Of course, PT will not be within the circle of mammals. However, there's no premise that says PT is a bird. So we have to keep PT outside the circle of mammals as well as outside the circle of birds. So PT should be somewhere within the universe but outside the circle of mammals as well as outside the circle of birds. All right, so this is a diagram based on the two premises. Now we will draw a diagram which will include the argument. So let's come up with that. Again, another square here, and then one circle for the mammal, another circle for the bird. All right, but if we were to take into account the argument, it says PT is a bird. That means PT, according to this argument, PT is going inside the circle of birds, all right, which is not the same that we got from the two premises, correct? So that's when we decide that this is an invalid argument. All right, this makes it an invalid argument because these two diagrams should match in order for it to be a valid argument. All right. So let's look at the solution provided. It says the first premise tells us that birds and mammals are disjoint sets, that is, sets that do not intersect. So if you recall, the first premise was that no birds are mammals, correct? So we had our mammals, a circle for mammals and then a circle for birds, and they are in no way connected because the premise said no bird is a mammal. And then the second premise said that PT is not a mammal. So we had drawn PT outside the circle of mammals, but we also had to keep it outside the circle of birds because there was no premise that said that PT is a bird. All right. So this is a valid argument. All right. However, the argument that was given for those two premises or based on those two premises said PT is a bird. All right, it said that PT is a bird. However, PT is not a bird. Nowhere in the premises is they say that PT is a bird. So since PT is not a bird, the argument is invalid or is a fallacy. So the argument was that PT is a bird, which it is not. Correct? Based on this diagram, PT should stay outside the circle of birds as well as mammals, and therefore the conclusion is the argument is invalid or is a fallacy. Now we'll look at a slightly different kind of syllogism. This one has the word some in its argument. So the argument given to us is all A's are B's. And then the second premise is some B's are C's. And then the argument is therefore some A's are C's. So we have to show by using the Euler diagrams, whether this argument at the end of the premises or based on the premises is valid or not. All right. So instead of working it first, I'm going to actually go through the next few slides and explain the solution that they have provided, because the second premise, some B's are C's, will cause several different types of Euler diagrams. All right, so let's go ahead and look at the diagrams first. This is the first step of the solution, which is the Euler diagram, which gives us the Euler diagram for the very first premise, all A's are B's. So what does this mean? All A's are B's means that if something is A, then it is also a B, correct? So that means all A's, the set of A's, comes entirely within the circle of B, within the set of B, right? So this diagram is for the very first premise. And there's only one diagram for the first premise, all A's are B's. That's very clear and straightforward. However, for the next premise, which is some B's are C's, you will note that we will be able to come up with 4 different diagrams, 4 possible ways that some B's can be C's. All right, so let's go on to the next slide to look at the Euler diagrams for some B's are C's. Now in this slide, we are going to come up with Euler diagrams for the second premise, which says some B's are C's. And as we see over here, we have 4 different diagrams. That means there are 4 different ways we can represent the same premise, some B's are C's. All right, so we're going to walk through these diagrams and try to understand how they are explaining, how they are representing some B's are C's in different ways, in different possible ways. However, let's just go over the first premise, the diagram for the first premise, which is also being used in these diagrams. But let's just quickly draw it over here. So we had our universe, right? And within the universe, we had a circle, a large circle for B. And it said all A's are B's, correct? All A's are B's. That means every A is also a part of B. So we had the set of A contained entirely within the set of B, right? So we will keep this, and now with this diagram, we will also build in the second premise. We will combine the second premise, some B's are C's, and we will see that there are 4 different ways we can represent that. All right. So in the first case, what happens is we see that the circle C is intersecting with the circle B. So yes, some B's are also a part of C. However, some A's, all right, the circle of A's is completely detached from the circle C. That means A has nothing to do with the circle C. Correct? So what this is saying is no A's are C's. All right, so A and C are completely disjoint sets, even though some B's are a part of C. A has nothing to do with C. All right, so as we can see that this particular diagram kind of refutes what the argument says. Argument says some A's are C's, but this particular diagram says no A's are C's. All right, let's look at the second one anyway. It's the same thing. We have the circle of B. Within it, we have the circle of A, but we have the circle of C intersecting with both B as well as A. So in this case, yes, all A's are B's, and then some B's are C's, and also some A's are part of C as well. All right, so there's an intersection between B, C, and A, and that satisfies the argument some A's are C's, correct? So this works. This is good. But then let's look at the next one. All right, what does the next one say? We have the circle B, and within it we have circle A, and we have the circle C, which completely encompasses the set A, correct? The A, this tells us that all A's are C's. All right, all A's are B's, and all A's are also C's. All right, so this also satisfies the argument that some A's are C's. And then we have the fourth case where all A's are within B's, all A's are B's, and all B's are C's. All right, so this too satisfies the argument that some A's are C's. All right, what does some mean? Some means at least one A is a C. All right, at least one element is a part of C. That's what it says. So this fourth one also satisfies the argument. However, the first one doesn't. Therefore, the conclusion would be that this is an invalid argument. So even though 3 of the 4 cases agree with the argument, the first one doesn't. Therefore, we have to annul the argument. We have to state that this is an invalid argument. All right? And here's the final step of the solution where we come to the conclusion that this was an invalid argument just because of the first diagram. All right, it's the first diagram that invalidates the entire argument, even though 3 of them agree with the argument. The first one doesn't, and therefore we have to say that the argument is invalid. Let's look at one last example. Again, we will use Euler diagrams to check whether the argument is valid or not, right? So the first premise is no fish are mammals. So how do we draw that one? The first one is, here's our universe, the square box, and within that there's fish and mammals, 2 sets, correct? So one set would be the set of mammals, and the other set would be the set of fish, and there's no intersection, there's no commonality, no fish are mammals, so they are disjoint sets. All right, there's no intersection. So we have a circle which is separate from the circle of fish, correct? And then the second premise says all cows are mammals. That means cows. Let's draw another Euler diagram for the second premise, and this is how it's going to look like. You're going to have a circle for the mammals, and you're going to have a circle for the fish, correct? And they are in no way connected. They are not touching each other at all. However, all cows are mammals is going to be represented by a circle within the mammals, within the set of mammals, correct? And then the argument is no fish are cows, and that agrees, right? No fish are cows means fish will not fall within the realm, within the circle of cows, and therefore this is a valid conclusion. This is a valid argument because it agrees with what the argument says. All right, it's when we build in the argument into our diagram, it is not different from what we got using our premise. All right, so therefore this should be considered a valid premise. So let's look at the solution here. It says the first premise tells us that fish and mammals are disjoint sets. There's no intersection, there's no commonality between the two sets, so they were separate circles. The second tells us that the set of cows is a subset of the set of mammals. So here we have the circle for fish, and then separate as a separate circle we have the red circle representing mammals, and within the mammals, within the circle of mammals, set of mammals, we have the set of cows, the circle of cows, because all cows are mammals. So the entire set of cows fall within the circle of mammals, correct? So what's then the conclusion? It says the conclusion necessarily follows from the premises and the argument is valid. So what was the argument? It said that no fish are cows, correct? Therefore, in this diagram, we see indeed that we do not have any intersection of fish with cows or cows with fishes. All right.